Good afternoon to all of you. Okay. So I'll take the attendance now. Okay, so we can start. Some students have joined now. Okay, good. I was talking something, but you have pointed out that I have my mic is off. Good thing. Please alert me whenever such thing happens. So I told that some students have joined late, so I will take once again attendance. So all remain present. And second thing is that I asked the question that do you remember what was the last topic which I covered? Anybody remembers? Anybody remembers? Now I am not mute. Now you are mute. What happened? Are you studying? What was the last topic which I covered? I didn't ask you to explain the topic. I only asked you to name the topic. Surprising. All are mute. Huh? Can you see this? Hill cipher. Okay. And I discussed the example also. And its script analysis and one-time pad cipher. These are the last topics. Okay. There is a discussion about rotor cipher and enigma. So these two topics you have to read from book. Okay, rotor cipher and enigma. These two topics you have to read from textbook chapter number 3. Okay, note it down, all of you. Okay, so I will start transposition cipher. A transposition cipher does not substitute one symbol for another. Instead, it changes the location of the symbols. If earlier ciphers, if we consider, then we were replacing one character with another character. But here what happens in transposition, it is changing the location of the character. Right? So the change is in the location. And because location is changed, the character is appearing is different. Okay, so a symbol in the first position of the plain text may appear in the 10th position of the cipher text. A symbol in the 8th position in the plain text may appear in the first position in the cipher text. Are you getting this? So transposition cipher reorders the symbols. Are you getting this point? Earlier we used to have one key because of it was shifting, right? But here it is reordering. So there is a permutation in the locations. Are you getting this, students? Type in a chat box. Okay. Okay. So first, there are two types of transposition ciphers. One is keyless and second is keyed transposition cipher. So first we discuss keyless transposition cipher. So in keyless transposition ciphers, there are two methods. The first method is that the text is written into a table column by column and then transmitted row by row. That is first method. So written in table column by column. So plain text is written not in the form of row. It will be first written in the column. Okay. So column 1, column 2, column 3. And then it is transmitted row by row. Okay. Second method is that text is written in a table row by row and then transmitted column by column. Okay. I think it is clear to all of you, this keyless transposition cipher. Yes. Okay. Okay. So first, let us consider this example. This example is rail fence cipher. Okay. So in this example, plain text is arranged in two lines and as a zigzag pattern. So the first character is written in the first position of first line and second character is written in the second position of the second line. Third character, third position, fourth character, fourth position, like that. So it is a zigzag pattern. So text is written in or arranged in zigzag pattern in two rows. Okay, two lines, we can say that. So if you read MEET, meet me at the park. So the plain text is meet me at the park. The cipher text is, so first read the first line. First read first line. Okay, and then read second line. Right. So cipher text is MEATEAK. Okay, then this is first line followed by second line ET ET HPR ET ET HPR. Is that clear to all of you? Right? So now how to perform decryption? So this is encrypted text. So Bob actually received this ciphertext. So Bob, how Bob will recover the plain text from this? So Bob will divide it into half. So this will be divided into half. The first half forms first row and the second half forms second row. Okay. Bob reads the result in a zigzag pattern. So if it is written in a first row MEMATEAA and ETETHPR, right? Then reads in zigzag pattern, then it will be able to recover. So Bob will be able to recover this text. Is that clear? Decryption is performed. Okay. So the cryptanalysis of this type of cipher is very easy as key is not used. Okay. So this is very easy to do the cryptanalysis. Second example, let us consider second example. In this method, Alice and Bob can agree on the number of columns and use second method. What is the second method? Text is written into table row by row and transmitted column by column. Okay. So Alice writes the same plain text row by row into table of 4 columns. So four letters appear in the first row, second four letter appears in the second row, third four letters appears in third row, and last three characters appear in the fourth row. Because we have taken table of 4 columns. That is why. So after writing this, we have to read it. We have to transmit it. So transmit it column by column. So MMPA, MMPA, EEHR, EAEK, TTP. Right? So you can see this is our ciphertext. Okay, so we write row by row and we transmit column by column. Is it clear to all of you? Okay. Now what happens? Bob receives the ciphertext and follows the reverse process. So in reverse process, what happens? The message is received and it is column by column. So the whole text is created. So this ciphertext is placed in column by column manner. Right? So first column, then first 4 letters in first column, second 4 letters in second column, like that. So it will eventually lead to this part. The last column is TTP. So this is TP. Okay. So receives the message column by column, and then it reads row by row. Right. If this is written in column by column and it is read row by row, then it is going to give us the desired plain text. So it is easy to discover the plain text if number of columns are known. Because what happened is Elias and Bob agree on the number of columns. So if the number of columns are known to you, who is doing cyber uh, object analysis, then it is easy for you to decipher the message. Okay. So what happened here? What is the length of the plain text? What is the length of the plain text in this particular text? What is the length? Please write down the length. You may ignore white spaces. Then what is the length of the text? Yo, I got 4 responses, 5 responses. Very good. Okay, now agreed number of columns agreed are 4 in this particular example. In this particular example, number of columns agreed are 4. So if you want to calculate number of rows, what you can do? Calculate number of rows if number of columns are known. Yes. Okay, yes. Okay, others, those who are present, you may understand it like this. Length of the plain text is 15 and the number of column equal to 4. It is known to both Alice and Bob. So the number of rows equal to upper bound or ceiling, as Yash has mentioned. Uh, Ceiling, right? So upper bound on the value. So 15 divided by 4 is equals to 4. Okay. If the plain text is 25, then how many rows will be required? Yash and Ronak, you are answering others. Explain the method. 25 divided by 4 because number of column remains same, that is agreed. So 25 divided by 4, that is 6 point something. So upper bound on that is, ceiling of that is 7, right? So or you can view it like this, that you have 4 columns. So you fill first row, you fill second row. This way you fill 6 rows. So there is still one character remaining. So that you insert in 7th row, right? So it results into 7. Is that clear? Yes, all of you? Is that clear? Okay. So now, third example. The In this example, we see that this example, the earlier example, this example which we have discussed, is actually having a pattern. Okay, we are identifying a pattern into this. So this table shows the permutation of each character in the plain text into the cipher text based on the position. So this plain text is converted into this cipher text, and that is based on the position that is explained in this third example. So if you look at 1 to 15 position, if it is plain text, it is 1 to 15 position. Okay, but it is reordered into this sequence: 1, 5, 9, 13, 2, 6, 10, 14, 3, 7, 11, 15, and 4, 8, 12. So what happens is, second character in the plain text has moved to the fifth position in the cipher text. So if you look at the position of second character, it is shifted to fifth position. Okay. Third character is shifted to ninth position. Right. So 1, 2, 3, 4. Fourth character is shifted to 13th position. Fifth, sixth, 7, 8, 9, 10, 11, 15, 13, 14, 15, right? Like that. 12, 13, 14, 15, like that. Okay. So the pattern in this permutation is 1, 5, 9, 13, 2, 6, 10, 14, 3, 7, 11, 15, and 4, 8, 4, 8, 12. So in each section, the difference between two adjacent numbers is 4. So if you take the difference between 5 and 1, it is 4. 9 and 8, it is 4. 9 and 13, it is 4. 2 and 6, it is 4. 6 and 10, it is 4. 10 and 14, it is 4. 3 and 7, 7 and 11, 11 and 15. And that is 4. 4, 8, 8, 12. So 4. Okay. So in each section, the difference between two adjacent numbers is 4. Is that understood? Okay. Now, so these ciphers were keyless cipher. Now we see key cipher, key transposition cipher. So in key transposition cipher, we have to divide the plain text into groups of predetermined size blocks, and then use a key to permute. Just a minute. Okay. Divide the plain text into group of predetermined size blocks, and then use a key to permute the characters in each block separately. Right? So you have to first get the characters into blocks and then apply the permutation. Yes, any noise is coming? All okay? All okay? Yes, is everything okay? Are you there? Okay. 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 So let us consider fourth example. So Alice and Bob have agreed to divide the text into group of 5 characters and then permute the characters in each group. So what you are doing is that your text is divided into group of blocks. So group size is decided and then the permutation is applied on that group. Okay. So the permutation is applied through a key. So you have a block and you have a key. And key is actually a permutation. Are you getting? So let us see the example. The key used in encryption and decryption is a permutation key. Okay, it is a permutation key. So let's take this key 31452. It is a key 31452. So this is our plain text and it is divided into 5 character groups. There are 4 such groups because the total number of characters are, what is the length of the key, sorry, plain text? Actually, if you read the sentence, the actual plain text is enemy attacks tonight. That is an extra. So we had actually 90 character actual plain text, but to fill the block, we have used 20 block, 20 characters. Is that clear? If you read the sentence, enemy attacks tonight, enemy attacks tonight. Z is not creating any meaning out of it. So Z is any extra character just to fill the block. Is that clear? Okay. So what we are doing is permutation key, using the permutation key. So first character is on third position. First character is on third position. Three, 1, 4, 5, 2. 3, 1, 4, 5, 2. Okay. So 3, 1, 4, 5, 2. So what was first that is remaining? What was third that becomes 1? What is third that becomes 2? First put third character, then put first character, then put fourth character, E, and N is fifth. Second character is 1. Third character is fourth. What is fourth? That becomes third character. Fourth character is fifth. What is fifth? That becomes fourth. And what is second? That becomes 5. So hypertext is the third character in the plain text block becomes the first character in the ciphertext block. Third character is first. First character in the plain text block becomes the second character in the ciphertext block. Okay. And so this results into this particular encrypted text. So Bob divides the cipher into 5 character group and using the key in the reverse order finds the plain text. Is this concept clear to all of you? So that I can move to the next topic. I guess you have understood it. Let's see how the encryption is carried out. So this is our ENEMY. So what is third? That comes first. What is first? That becomes second. What is fourth? That becomes third. What is fifth? That becomes fourth. What is second? That becomes fifth. Is that clear? Okay, so now try these three other blocks. Verify that 31452 is applied over here and here and here, and write down in the chat box that you have verified that it is following this order 31452. Do this exercise right now. In 2 minutes, you can finish. Yes, will you be able to do it? In 2 minutes, you have to answer. Right, so let me explain you. A is first character, but as per this, third character should be first. So third character should be first. First character should be second. Third character should be fourth. Fifth character is second. Okay. Have you tested? Please write in the chat box. Okay. So when you read your row, so you get is EEMYN TAAC T TKONS HTN. So what is happening? We have encrypted 31452. Okay, you can see this. This shows you actually the decryption key also. And this is our encryption key, and we are generating the decryption key. Please pay attention to this topic. It is little bit of confusing, but once I explain you and you understand it, it will be very easy for you to develop decryption key. So this 31452 is in the first 5 position. So what has happened is first position is second, fourth position is third, fifth position is fourth, second position is fifth. Is that clear to all of these? Third is first position, second is fifth position. Okay. So now we want to generate decryption key. So first position, first is on second position. So second is on first position. Second is on first position. Fifth is on second position. Second is on fifth position. So fifth is on second position. Okay. Reverse we have to see. One is on third position. And fourth is on third position. And fifth is on fourth position. Is this clear to all of you? Decryption key. Is decryption key clear to all of you? Only 2 students have written. Others, have you understood this decryption key? Then apply the decryption key on this block. Suppose you have this decryption and apply this decryption key to 25134. Are you getting the words bit for first block? Check it and type in the box that you have tested it is correct. Can all of you do this exercise in your book? Have you tested? Okay. One student has written. So let us see it here. Decryption key is 25134. So what is set? First character. This first character. Key 2 means what? Decryption key 2 means what? 25134. What do you mean by 2 here? Can anyone tell? What is the meaning of 2? Which second letter is at first position. Second letter is at first position. First is shifted to 2. Which is, first is shifted to 2. But we have to recover this plain text. Second character is in first position. Second character in first position. Fifth character on second position. Fifth character is on second position. E-N. E. First character is on third position. Fourth character is on third position. Sorry. Third character is on fourth position. And fourth character is on fifth position. Can understood all of you? So similarly, you can do it for other blocks. And so the plain text returned is enemy attacks tonight. Is that understood to all of you? Yes, others. Please write. Understood this? How we apply decryption key? Do it for third block. So for third block, second character appears first, fifth character appears second, first character appears third, third character appears fourth. Okay, and then the last one is second is on fourth character is on fifth. Fourth character is on fifth. Understood? Okay. So I'm getting responses from Keval and B. Okay, so some students are basically attending it properly. Now, third approach is combining two approach. Combining two approaches, the plain text is this: enemy attacks tonight Z. So the combined approach, the first step, first thing we do is we write row by row. Okay, so we write row by row. Enemy attacks today or tonight. This n is supposed to be small. Okay, so first we write it in row, and it is assumed that the number of columns are 5, and that is why we are writing it in 5 columns. Is that clear? 5 columns. Second step is use key to permute the columns. First we write in rows by fixing the number of columns. First we write it in rows. Then we take permutation as a key to permute this text, and then we read it column by column. So it is combination of two approach. Is that clear? Combination. Okay. So first and second results into this. If we read column by column, ETTH, EAKI, MAOT, YC and Z, NT and NTSG. So in this example, the key is used, but the key is with respect to the instrument. Okay, instrument in the sense that if we have suppose if we want to make an instrument which will perform encryption, just imagine that we are designing some hardware. 4 is T in 14th slide. Why? It is Y. Got it? Yes. NIGHT. Yes. Let me correct it. Okay. All right. So I have done it. So I was talking about some hardware. Suppose you have a machine which will perform this encryption. So what we have to do is that you have to place these characters and then you have to permute. So you can imagine some mechanical device or some electronics device which will perform this combination. So till now you are thinking about software only, but now just imagine some instrument which can be designed which will perform this encryption. Okay, so Enigma was one such machine. Okay, so first we are combining these two approaches. First we write row by row, then we use permutation key, and then we read column by column. ETTH, EAKI, MAOT, YCNZ, NTSG. Right? So this is our combination of the approach. First approach, create row by row, apply the keyed transposition, and then read column by column. So at the decryption side, the number of columns are known. Okay, number of columns are known. So the length is 20. Length is 20. So the number of columns are 5. We use 20 as a length. In this particular ciphertext, we have how much length? 20. And the number of columns are 5. So what we do, we first put column by column, 5 columns. So it generates 4 rows. So 20 by 5 is 4. Is that clear? If the length is known, number of columns are known, so you can find out number of rows. So eventually it will give us 4 rows, each row with 5 columns. Is that clear? Yes, to all of you understood what we have done? This decryption. So at the time of decryption, we receive these as a ciphertext. So ciphertext has to be arranged in a proper manner. So that manner is put it column by column. ETTH, ETTH, EAKI, MAOT, EETH, EAKI, MAOT, ICNZ, NTSG, ICNZ, NTSG. Is that clear? So first we write column by column giving decryption. Okay. So first the ciphertext which we have received, that we have put into column by column. Then we are applying this key. Decryption key is, encryption is with this key. Decryption is with this key, 25134. And that key is used to permute the column. So it should result into our plain text, and then we read it by. Clear? All of you? Okay. So now we perform cryptanalysis. So first method is brute force. So assume that ciphertext length is L. So transposition cipher cryptanalysis. So assume that ciphertext length is L and we don't know the length of the key. Length is L, but we don't know the length. Okay. So we can assume key length and then proceed for cryptanalysis. Now once what we know is that this key is basically a permutation. Okay, that is what we know. So let's take this plain text Enigma. Enigma is a plain text, but as I told you, Enigma is also a machine, and which was used during Second World War. So I told you in the beginning that you are required to read about rotor cipher and Enigma from the textbook. So let's consider enigma as a word. So key is 312. Okay. So E and I, first three characters. It is a three character length of key. So 312 is the key. So E and I is converted, E is put into third position. Sorry, uh, N is put into first position is third character, second position is first character, and third position is second character. So I, E, N. First character is first position is third character, second position is first character, and third position is second character. Is it clear? So IEN becomes our ciphertext. Now, IEN we want to apply brute force. So when we are applying brute force, we don't know the length. You have to guess the length and then guess the key. So here the key length is 1. If we take key equal to 1, then it is not possible because character is permuted by itself and so no permutation. Now suppose second is key length equal to 2. So we have two possibilities, 1, 2 and 2, 1. But 1, 2 is not satisfied because 1, 2 means it is as it is. Nothing to change. So it is not applying any permutation. So we apply 2. So after dividing the ciphertext into blocks of 2 characters, we get EING, NAMG, EI, NA, EI, NAMG. We get ciphertext equal to EI, NAMG. Now, if we do this, so EI, this is the ciphertext which we have received, and by applying 2, 1 as a length, we are getting EI and ANMG, and this does not make any sense. Okay, this is not any meaningful text. So we guess the key length, that is 3. So for 3 key length, we have 3 factorial possibilities, that is 6. So these 6 possibilities are 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, 3, 2, 1. Okay. So if we try 1, 2, 3 is not possible because it is keeping the text as it is. So we try second key, that is 1, 3, 2. So IEN is first is put into third position, third is put into first position, second is put into third position, and third is put into first position. So we have IEN, AGN. Then we try 2, 3, 1 as a possibility. So what we get is ENI. E, second position. So from here we have to see 2, 3, 1. 2, 3, 1 is the key. 2, E, second is first. 3, ENI. ENI. Okay, 2, 3, 1, 2, 3, 1. So if we reorder the 3 blocks of ciphertext into 2, 3, 1, 2, 3, 1, it results into decryption. So the number of brute force trials required are factorial plus 3 factorial plus 4 factorial plus L factorial. where L is the ciphertext length. So sigma I factorial for I equal to 2 to L. This is clear to all of you? Understood? Number of tiles required. Yeah, all of you. Number of tiles required. Please type in a chat box. What have you not understood? See, what we have done is first key length 1 is making no sense. Key length 2 makes two possibilities. 2 factorial is 2. So 2 possibilities. First possibility is making no sense. So 2 1 is applied. We found that it is not useful. So third key length is guessed. Key length is 3. With 3 we have 6 possibilities. That is 6 factorial. Sorry, 3 factorial. That is 6. And so these are 6 possibilities. Okay, we apply one by one. So 2 factorial plus 3 factorial plus 4 factorial plus up to L factorial. So here in this particular case we get these 6. It does not mean that every time we get it here. We may not get in 3 factorial of any of these. So we may have to try 4 factorial. Okay, are you getting Shailesh? Right? So this results into a summation of L factorial. So sigma I factorial from for I equal to 2 to L. That is going to be our brute force styles required. Okay. So I will discuss the pattern approach in the next class. I hope that you have understood. I already taken the attendance. And the same will be followed. I suggest you to be online every time. On Friday also will be taking lecture. Okay.